Hello, my friends. In the last chapters, in the last video, we have talked about the vector form of Coulomb's law. And in this chapter, we are going to use the Coulomb law to express another variable, another more important parameters. So what we have learned yesterday is the formula for Coulomb law. And this Coulomb force represents the force between two charged objects. Where d is the distance between them. In many cases, our concern is not two charges or the force. Our concern is to take advantage of this formula and use this formula to detect the presence of one charge. And this could be any charged object. The Earth itself is a negatively charged object. The Sun is another charged object. Almost everything on Earth is a charged object. The amount of charge is just up to us to detect it. So very often you are only given only one object and your interest is in its charge. So how are we going to detect it? This is the question. Can we take advantage of this formula? The question is yes. What we can do is, instead of having two charges in a system, we only need one charge for detection. We are going to detect the presence of Q1. So what we can do is represent this one as a charger as a sensor. So this one becomes a sensor, and it contains a big Q. According to this formula, the interaction force between Q1 and this big Q is F. Now the formula, the Coulomb law's formula, has two variables. Have three variables, right? Force. Another variable is Q1. Another one is big Q. Three unknowns. But in this case, we are going to use the sensor to detect the presence of Q1. So what can we do? We can invent another variable. Move Q1 to the left side. And this variable is so-called electric field. And We call this variable electric field or electric field strength. In vector forms, these electric fields can be expressed as E and then Q1 4 pi epsilon, and do not forget D to the power 3. So this is the vector form of electric field. This is just an extension of the original formula of Coulomb's law.